Why do we always use these types of examples in mathematics? Like, why are we going down to the shops and buying 24 watermelons? No one does that. And then in this situation, we have a bag of marbles. There's 6 green marbles and 4 red marbles. And when are we ever trying to work out the probability of drawing marbles out of a bag? Obviously, it's just a tool to try and teach you the logic of the multi-stage event for whatever multi-stage event could occur in the future. Probably not drawing marbles out of a bag. But in this question, the marbles are not replaced, so it's without replacement. And the question is, what's the probability of drawing out one of each color? Now, in the advanced mathematics syllabus, you're required to be able to interpret these with tree diagrams. So I'm going to do the solution via a tree diagram. So let's move this up here and say we could get a red out first and then a green, and then we could get another red and then a green, or another red and another green. Now you might say, hey John, you didn't put all the outcomes out there. There's 6 greens. Where are they all on the tree diagram? Well, as long as the tree diagram has the probability for the outcomes, you don't need all of the outcomes. So there was 4 reds out of the 10 marbles and 6 greens out of the 10 marbles. But if we take a red out and don't replace it, well, then there's only 3 left out of 9, and the greens have still got 6 out of the 9. And down here, if we took a green out, we've still got our 4 reds out of 9, and then we've got 5 greens out of 9. Now, if you were ever doing calculations across a branch, you should always be multiplying, because this is the multi-stage event, red and green, red and red. So this is our and if you're ever adding branches together, then that should be our or. So red and red or red and green. So we always try and use these terms in probability. So let's go and calculate some of these fractions. So what we're after is the ones that are not the same, green, red, and red, green. So we've got 4 over 10 times 6 over 9. And we've got 6 over 10 times 4 over 9. And so we go and put those together, and 6 fours are 24 over 90, 10 nines, and the other one's the same, 24 over 90, and we end up getting 48 out of 90, which we would not be able to walk away without simplifying, because that would just feel terrible. And we get 24 out of 45, and that's the probability of getting 1 red and 1 green in any order out of a multi-stage event for drawing those out. Link in the bottom in the comments for the full video explanation at my YouTube page.